Hi guys, welcome to my channel. This is The Great Tech. Basically in this channel we discuss about tech related videos. I and my team come up with educative videos that will help to develop your repair skill. So if you're coming across this channel for the first time, please subscribe to our channel, and at the end of this video, if this video is helpful, you can give us a like, and also if you have any question, comment below and I promise I will reply to your question. So without wasting much of your time, let's dive straight into the video of today. Okay guys, welcome to this channel. This is The Great Tech. So in today's video I'll show you how to use most parts of the schematic diagram. We're going to be talking about schematic diagram, bitmap, and also the board view, component distribution on the logic board. But basically today I'm going to be showing you guys about the component distribution. Then if we have much time, we'll move to the next one. Okay, so without wasting much of your time, I'm going to be using the iPhone logic board and also the Android logic board. But for Android I'll be using Samsung. Okay, I'll be using Samsung, and I'll be using oppo. Okay, so without wasting much of your time, let's dive straight into the business of today. Okay, so let's go straight to the iPhone. Okay, now this is the iPhone. I'll be going straight to, let me use the iPhone 6. Okay, let me use the iPhone 6. That is okay, let me use the iPhone 6. Where's the iPhone 6? Yeah. Okay, so now this iPhone 6, under this iPhone 6 we have what we call the iPhone 6 bitmap, the iPhone 6 schematic. Okay, and lastly we have the iPhone 6 circuit block diagram. Okay, the iPhone 6 MLB component distribution, and the iPhone 6 malfunction map. Okay, so first of all I'm going to be showing you guys today I'll be dealing on the topic, this circuit block diagram. No, sorry, I'll be dealing on the topic the MLB component distribution. Okay, so we'll go straight to this and I'll show you some of the basic components on the logic board and how to identify them. Okay, so now let me dive straight to that. Let me click it. Okay, this basically you use your computer system to do this operation. You don't use your phone. Okay, so let's wait for it to load. Okay, let's wait for it to load. Let's give it some time to load. Okay, now boom, it has already loaded. Okay, so now this is the component distribution. Okay, so now this is what we're going to be doing. I'm going to be showing you most of the basic. This is how the iPhone 6 logic board looks like. Okay, let me zoom it a little bit for you guys to see. Okay, so so this is how the logic board looks like, the back and the front. Okay, this is the front layer. Right here is the front layer, and right here is the back layer. Okay, so now I'll be showing you guys how the front layer looks like. Let me zoom it back. Okay, I'll zoom it. So this is how the logic board looks like. So I'll be showing you some of these basic components on this logic board, like some of the most ICs and how that is the component distribution on this logic board. So without wasting much of time, let me dive straight to it. Okay, let me zoom this front, like the upper layer of the iPhone 6 logic board. Okay, I'll be using the iPhone 6, so I'll also use the iPhone X for this operation also. Okay, so now I've zoomed it a little bit. Okay, so this is the logic board. Okay, so now this is the logic board. I haven't known that this is the logic board. Okay, from the iPhone 6 we have different section. Okay, we have this module here. This side is for mute and the connector. There's a side button close to the iPhone 6 that you can easily put on vibration and unmute it. So this is where the flex is connected. And if you have been following my topics and my previous videos, I do talk about what we call like if you want to read a schematic diagram or a board view or a bitmap, then you need to know some of those basic components. They are what they use in identifying them in the logic board. Okay, on the schematic. Okay, so I said anything flex or connector they use J to represent it. Okay, and I said anything IC we use U. Okay, so if you have not checked the previous video, you can go back and check it and you understand very well what I mean. So without wasting much of your time, let's dive straight to what we have today. So this J here is for the mutes and the mute volume mutes and unmute. Okay, so why this here is the power and flash vice microphone connector. Okay, so that is for that. That is I'll just be brief about this. Okay, so this right here, this one here is where the power flex, that is the power button, is connected. Okay, so this is the connector for that, and this for look at the number of this connector, that is J0801. That these numbers, those are we call them the components. Their names given to those components. Sorry, I think my system is a bit giving some issue. Let me work on it. Okay, let's dive straight, let's continue. Okay, these numbers written on these connectors, they are not the value of the connector. Okay, what that number signifies is that maybe they may have like more than 100 connectors on this logic board, so they do number label those connectors according to their number. They may label this first one that is here, this first one, as J1. Okay, the next one they will label it J2. Okay, that is connector 1, connector 2. Okay, you understand what I'm trying to say? So that is how it is. Okay, so now this is for this number, this one right here is for the power section. Okay, so let me move further, let me move it. Okay, so this right here is for the rear camera. Okay, that is the rear camera connector flex. Okay, that is for this one. Okay, so right here we have the display connector, that is the screen connector. Okay, that is this rear camera right here is for the back camera. Okay, you see that is the connector. Look at the number of the connector. Okay, so right here is the front camera connector. This is the flex, this is the clip. Okay, so this one right here is for the display, that is your screen connector. Okay, why here the screen connector, remember it do come with the two main flex, the touch flex and the screen connector flex. So when you are purchasing a new screen, it do come with two flex, the display connector and the touch connector, that is the touch pad. Okay, so this touch connector is for the touch pad. Okay, that is for if the touch pad of the iPhone 6 is not working fine, you just go straight to this place to see if you can rectify the problem from this place, maybe by servicing this clip instead of going to this one doing some calculation work, that like guesswork. You knowing this basic, and once you have the application to view all this logic board, you just go straight to the problem and rectify it immediately. You understand what I'm trying to say? So this right here is the touch connector flex. Okay, so right here we have this one, we have the touch ID connector, that is the fingerprint sensor connector. Okay, this is this one right here is the flex for the fingerprint connector. Okay, so right here I'll be showing you guys more of it. Okay, this one, this IC here is your CPU, and this is an A8 CPU processor chip. Okay, that is your central processing unit, is like the brain of this logic board. Okay, so it's like the brain of this logic board. So, and I told you guys on the previous video that ICs are being that is integrated circuits on the schematic diagram, or the bitmap, or the board view, or the component distribution board. That is the view on the schematic diagram application. They are being represented with U. Okay, they are being represented with U. So this IC right here is represented with U and is the A8 CPU, and this is the part number of the IC. Okay, this IC, this number right here is not the value of the IC. Remember, I told you guys that it is very why the programmers, that is the OEM, that is the OMEs, that is the original manufacturers. Okay, why they label this these ICs and components is so that if you are looking, if you want to find a component, like if you want to work on a particular IC or a component, you won't be looking further searching for different like doing too much search on the schematic diagram. You just go straight to this place written find, then you just input the number of the value of that component and it will just take you directly to that place. Okay, for instance, this, let me use this example, like this component here, this is the IC U0201. okay, let's find it here. Let me type it U0201. okay, have you seen, once I click on it, you see this stuff highlighted on its own. So that is, it will be very easy for us to locate that particular component by typing it. Okay, and right here the search just shows that this is the CPU, that is the A8 CPU. okay, right here. Okay, so that is how it is. Okay, let me clear that. Now let's continue my explanation. Okay, now that is for the IC. okay, here, right here is for sim connector. okay, anything, I told you, anything connector is being labeled with J, be it screen connector or anything connector at all. Like this SIM card connector is being labeled with J3101. okay, that is the SIM card connector. okay, let's move further. This is the an IC, another IC, that is the name is the accelerator. okay, so this is the IC. okay, this one right here is the RF amplifier. That is this right here, this IC right here is the RF amplifier power IC. okay, RF means radio frequency. okay, so that is for that. okay, if you want to know more of those components, we'll discuss that maybe in my previous next videos that I'll be making. okay, so now this right here, just know how the ICs are being labeled. okay, so right here is the this one right here now is the RF antenna switch. okay, is a component also. okay, so this right here, this one right here is the battery connector clip. okay, you see it's being, because the connector is being labeled J. okay, remember what I told you. okay, so this right here is the charger connector, that is the connector for the downboard. okay, that is for this one, that is the connector for the downboard. okay, so that is for that. So moving forward, you just, what I want you guys to know is that this application can help you identify, like, get, as in, without you knowing, being are so broad in knowledge, you can just use this application to just know the particular component that you want to work on and their location. okay, so you don't need to stress yourself, you just go straight to the application. okay, and it will pop out all this for you, and the application can only work on computer system. okay, so at the end of the video I'll be telling you guys how to get this application. okay, so without wasting much of time, let's dive straight, let's continue what we're doing. So all these chipsets are being labeled, and all these ICs are being labeled. Like this IC right here is being labeled U. okay, so it's the 3G amplifier. So this one right here is for for anything network. Even this RF amplifier power is also for anything network. okay, we'll be deliberating on the IC and the components, how they works. We'll be deliberating on that on this particular video. This video is just meant to enlighten you. So let's go, let's move further, let me move further, let me see. okay, let me zoom it in, let me zoom it. okay, so now let me show you how the backboard looks like. This right here is the backboard. okay, so let me zoom it for you to see. Let me go, be moving faster for you to understand. okay, so because the video is very long, so I'll try my best to make it a bit short. okay, so right here is the Wi-Fi Bluetooth IC. So if your mobile phone is not having a Wi-Fi connector, like the baseband is missing, is not connecting to Wi-Fi, or that is the iPhone is not connecting to Wi-Fi, or is not working, so the best thing, what you need to know and what you need to do there is you just go straight to your board view, that is your component distribution on your application, and it will directly type and search for that particular IC, and it will pop it out, and you won't be stressing yourself as a technician, an advanced professional technician. You just go straight to that component and fix it. Like this IC right here, if you don't know, you may not know the value and the component name and their work. So if you are just a novice and maybe you are coming up and maybe you have a coach that coach you, then you just know that and you have this particular application on your system, it will be very easy for you to just troubleshoot and know the work of that particular IC, and you just go straight to that and rectify the problem without wasting your time. Like for instance, if this board is not having a Bluetooth connector, like the Bluetooth is not connecting and the Wi-Fi is not connecting, you just go straight to this IC. Maybe if you heat it up a little bit, if it refuses to work, you remove it and reball it, then replace it. If it still doesn't work, you now change it with a new one. So that is how it works. Okay, so that is for the Bluetooth and the Wi-Fi IC. So this is the touchpad IC. So if your mobile phone is having a touchpad problem, directly just go straight to this place and rectify the problem without wasting much of your time going heating up the whole board or servicing the whole board. You just go straight to this particular place and rectify that issue immediately, and the mobile phone will start working perfectly. So that is how it is. Okay, so this is the touch control IC. Okay, this is the touch IC. Okay, so this one is the touch control IC, this glass IC, all of them works as the touchpad IC. Okay, so this so some logic board. Okay, I won't be going straight and deep into that, but just know that some logic board on an iPhone, like I have a current problem I fixed maybe previous just not long ago. I have a current problem like this, I rectified. The customer came to the shop and complained that a technician tried fixing the mobile phone, like they tried replacing a new screen and the mobile phone still can't respond, still can't touch even after replacing a new LCD. So I just know that that is a touchpad IC problem. So I just had to go straight to the direction where the touchpad IC is, remove it and reball it and replace it, and the mobile phone start working perfectly. So that is how repair works. It is very very, I told you, I used to tell my students that repair is very very simple. It's just for you to, number one, have your tools, number one, be knowledge, have that knowledge. Okay, even though you pay for that knowledge, in order to acquire that knowledge, it's very important you acquire that knowledge. Once you have acquired that knowledge, it is very simple. The repair will be very easy for you. Okay, so now moving forward, this is another IC, the audio IC. Okay, so that is for this one right here is the compass IC. Okay, that is for the compass IC. So let's move straight. Okay, this IC right here is the PMU, that is the power management unit IC. So that is for that. So this right here is the logic chip IC. Okay, this barometer IC, this one is not this barometer now is this one right here. Okay, so all of them are, their names are written on that logic board, nothing you want to find. This one now is the NAND flash, that is the is just serve as the eMMC, that is the internal storage device of that logic board. This is for an iPhone. This is the NAND. Okay, let's move. This is the CLK crystal. Okay, that is for, also works as for that is an oscillator. I'll be going deep on that, so we'll just rush and so that we'll move to the schematic diagram. This one is just component distribution. Okay, so this is the RF IC, the speaker amplifier IC. So if you're okay, so this one is vibrator controller. All the ICs are labeled. Okay, all of them are here. This one right here now is the charging IC, that is this one right here is the U1401. This is the charging IC, this is the main charging IC, and also this one here is the USB IC. Okay, this is the USB control IC. So that is how it is. Okay, so moving forward, let me zoom it in back. So I hope you guys have understood what I mean by this place. So let me use an oppo board to explain further, using that is an Android. Okay, I've shown you guys on iPhone, so let's move to Android. So this is oppo. Let me see oppo A71. Let me see oppo A. Okay, let me check, let me see if I can see the one that have component distribution. Oh, this is part number diagram. Okay, let's wait for it to load up. Okay. Okay, this one right here is an oppo. Okay, let me check this schematic diagram for this is oppo A71. Okay, let me check the schematic diagram. Let me zoom it. Okay, this is how schematic diagram looks like. Okay, for those that have been telling about schematic diagram, this is how it looks like. Okay, let me zoom it a little bit for you to see. Okay, this is the schematic diagram. Okay, so first of all, I'll be showing you guys, before going to the schematic diagram, I'll be showing you guys, let me show you guys what I mean by let me show you what I mean by bitmap. Let's go back to the iPhone. Later we'll come back to the Android. Let's be done. When we are done with iPhone, we'll come back to the Android. So this is for iPhone. Let me check this iPhone 6. We are done with the component distribution on iPhone 6. Okay, straight we'll be moving to the iPhone 6 bitmap. Okay, let's wait so that it will load. Okay, let's wait for the iPhone 6 bitmap to load. Okay, now it has successfully loaded. Okay, that logic board we see previously on the first video. This is the second video of this is what we call bitmap. We call this stuff bitmap. Bitmap is quite different from component distribution. Okay, bitmap is different from component distribution. The bitmap is just like a should I say is like okay, the bitmap is just used to explain. It's similar, somehow similar to the component distribution, but the difference, it shows all the connection made on the logic board. That is the difference between the bitmap and the component distribution. Okay, the bitmap shows all the connection, because in a circuit board, that is a logic board or a PCB board, a printed circuit board, the connections there that are made are very tiny. The wires of connections are very tiny. Sometimes you can't see them with your clear eyes. You need to use a microscope in order to view them. Okay, but the manufacturers, this developers, software developers, come up with an interesting idea to come up with such application that will help engineers and technicians in troubleshooting. Okay, I'll be showing you guys how this bitmap works. Okay, I'll be showing you guys how this bitmap works. Okay, let me zoom this first board. This is the back board of the iPhone 6 and this is the front board. Okay, so let me zoom this front board first for you guys to see very well. Okay, let me zoom it, let me take it. Okay, let me zoom it a little bit bigger. Okay, so this is how the board looks like. Okay, let me zoom it in so that you can see what I'm trying to say. Okay, this is how the board looks like, the bitmap. Okay, so this right here is, you remember the connector is the main, you can see the right up there, that is the part main camera connector. Okay, and also this one here, you see all the connectors are labeled, and this is the IC. Okay, the IC now, the bitmap shows you the, as in how the board is made without those chipsets on it, without those components on it. Okay, it shows you how the circuit is being designed, has been designed graphically. It's like a vector graphic image that shows you how the logic board was manufactured. Because before a logic board is being manufactured, they will first of all design how the logic board is going to be on the system. Okay, in my next and maybe my next videos that I'll be making with time, if you keep following me up, you come across some of the videos that I will make that talks about how to design a logic board, and I will show you a practical example on how logic board are being designed using the computer system. And after designing it, you now work it, and it will work perfectly as you design it on the computer system. So this vector image, that is the bitmap, has been designed by the manufacturers even before they start producing the logic board. Okay, so this now is the pure example of how the schema, the bitmap is being, and the logic board is being manufactured on software view. Okay, so now this video, these pictures you guys are seeing right here is called bitmap. Okay, and this bitmap right here now is like, just there are no component attached to it. Like the component distribution, there are component attached to it, but right here there are no component. It just shows you the, as in the lines of connections made on that logic board. Okay, the lines of connection made on that logic board. Okay, let me zoom this first board a little bit for you to see what I'm trying to say. Okay, let me zoom it up a little bit. Okay, let me bring it down. Okay, you see the first connector, that is for the rear camera. The second connector, that is for the touchpad. This one for the screen. Okay, yeah, the display. And right here is for the front camera. Sorry, this one is for rear camera, the back camera. This is for front camera. This is the fingerprint button. Okay, these are CPU. Okay, these are CPU. And if you see right here, I told you guys when we are studying about schematic diagram basic, okay, that the J is being represented is for connectors now, and the C, like right here, is written C2181. This is a capacitor. Okay, I've explained everything about this for you guys in my previous video. Okay, let me zoom it. I've zoomed it a little bit. Okay, so right here you see this, you see a filter. These are filters. Okay, is represented by FL, and this C is for capacitor. Okay, this right here is a capacitor, this right here is a capacitor, this is a capacitor, this is a capacitor C, and here right here is a a resistor. It's being represented by R. Okay, this is a resistor. Okay, so now let me move further. Okay, let me zoom it a little bit, let me zoom it out. Okay, now this is how the diagram looks. All the components on that logic board, all of them are being specified and explained in a diagram form on this stuff here. Right here, the connections have been made. They are just showing you how those board looks like. Now let me show you what I mean by the connections has been made. Okay, now for instance, you have a broken connection. Let me say an open circuit. I remember when I've taught you guys, those in my VIP class and those that I'm mentoring for this for the present time right now, I've taught you guys about what we call open circuit and short circuit. Okay, now open circuit is when there's no the connection is not completed, there's a broken connection. Okay, now it will make the current not to flow from part A to part B, so that broken connection now may make the flow not to come on. And short circuit also is when it's being shorted, not allowing current to pass. When it's being shorted, like when there is a short circuit, I won't be going deep on that explaining that. If you have not joined my VIP class, you can join it and you know more about what I'm trying to say. So now this connection, for instance, there's a broken connection. Let me show you. Once I click on this, once I click on that, now I've clicked on it, it's showing red. Now you observe something. Anywhere that component is connected to will show red. Okay, anywhere that component is connected to will show red. Okay, can you see now? I click on this. This right here is should I say that is that is LO. That is, let me, yeah, is LU12. That, and LU is for inductor. Okay, this inductor right here is connected to this CPU chipset. This, look, sorry, this chipset here is connected to this chipset. Okay, have you seen that red dot there? Okay, let me look for another place that is connected to. And you can practicalize this using a fresh board. You guys can do that as an example using a fresh board. You see what I'm trying to say. Okay, what I'm trying to explain. Okay, let me get another dot. Let me keep this dot right here. Let me touch it, let me click it. Okay, let me look for a dot that maybe is connected to something. Okay, this dot right here is connected to this dot. If you spot very well, let me zoom it. Let me take it up. Okay, this dot right here now, once I click on it, it's connected to this and it's also connected to this. So if you are using your multimeter and is on continuity mode, once you put it here, and you put the positive probe here, it's supposed to beep with this. It's supposed to beep with this guy. Once you connect the both of them, it will show you that they are beeping, that is, they are connected. And also once you even connect it with here, it will show you that they are connected. Okay, so let me move forward. Let me show you this battery connector. Okay, this right here is a battery connector. Okay, now this battery connector now right here now is the let me say this side is the negative terminal, and maybe here is the positive terminal. So let me click on this terminal right here. Let me click on it. As you can see, this guy is connected to this guy, this guy is connected to this guy. So if you are using your multimeter to check, you see that this guy is connected to this guy and this guy is connected to this place. Okay, so once I click on that, this one right here is ground, this one right here is ground, this one that is I click. Let me remove it from there. So if you notice all these, see all these dark ones, they are the common. Okay, those are the they are called the ground. So let me connect it again. Let me connect it so that you see that is the negative terminal, that is ground. Okay, they are grounded. All this, if you notice all this black stuff, those ones are the ground, they are grounded. Okay, they are grounded. Okay, let me turn the board upside down for you to understand, or let me reverse it back. Sorry, let me reverse it back. Okay, let's go so that you understand what I'm trying to say. Okay, so that is for this battery connector right here. Let me still rotate it. You can rotate it anyhow you want. You can rotate the board anyhow you want, so for you to get a better view. Okay, so now this guy, remember this logic board, they just show you the front and the back. So that is to say this guy now right here is the positive terminal, and this positive terminal is connected to this place. You can do the experiment tomorrow or anytime, only of a convenient time, you can do the experiment. If you see this, once I click on, let me click on another one, this one right here, you see that it will show you every part that it is connected to. Let's look for the connection where it's connected to. Okay, let me come down, let me go up. Okay, she's connected to this place. Okay, and it's also connected to here. So once I click on it, it will show you every pin out that is connected to. So just know that it shows this is a very basic, as in it explains how the logic board is made, how they are designed. Okay, it explains everything about that logic board, how they are designed. Okay, so let me zoom in. I'm trying to make this video a little bit fast for you guys to understand. So let me click on this. Bam, let me click on it. Once I've clicked on it, let me zoom it out. Let me zoom it out for you to understand. Okay, that doesn't show much connection there. Okay, let me look for someone that, okay, let's go straight to the connector flex, so that, because all these ones I'm clicking are IC chipset, and they are let me zoom it, and you can't easily read them without removing those IC. Okay, you can't read them without removing the IC. So but as I hope you guys are understanding what I'm trying to say. Okay, once I click on this red dot here now, you notice that all the places that they are connected shows indicated red. Okay, even this one right here, this guy right here, what the part number is LU, that is an inductor, and also this is LU, that is an inductor also. They are connected to all this red. Even let me see the backboard. Okay, this right here, this is a capacitor, this also is a capacitor, that is C. Okay, you can see where it's written part number C1240. Okay, that is how it is. Okay, that is how it is. So we are going straight, we will still go straight to the schematic diagram. Okay, so for you to know the value of those components, but for now you just need to know the how I'm trying, just follow what I'm trying to explain. Okay, let's use this flex, this right here. You understand when I was explaining to you guys that this is the we call it, this right here is J, is used to represent connectors. Okay, J is used to represent connectors. Okay, so now right here, now let me zoom it, a little bit, let me zoom it a little bit. Okay, let me zoom it a little bit okay, yeah, that is it. So now this one right here, now let me zoom, I've zoomed it a little bit. Now this one right here, this flex right here, is the touchpad flex. So let me click on this to show you. It is, you see that this connection is connected to this place. Once I just click on it, it indicates that it's connected to this place. And if I'm using my multimeter to read, once I bridge my multimeter red probe here and my black here, it will definitely beep on the multimeter, that to show that it's continuity. But if it does, after checking it on your bitmap and you try using your multimeter to check it on the logic board and it does not beep, know that that logic board is faulty. That is to say, you need to make a jumper from here to here for that connection to be completed and the logic board will start working. Because if the connection is not completed, the touchpad may not function. Okay, so this right here also, and if you observe very well, let me zoom it out for you to observe what I'm trying to do. This is the touch connector. Remember from the component distribution, I said that this is the touchpad IC at the back of the logic board. When I was making the explanation, you can go back. No, once I click on this pin, it will indicate where it's connected on that IC, the IC terminals. So this right here now is connected to this pin out of this. You understand what I'm trying to say? So this one right here now, let me check. This one right here is connected to this one. You can be checking this, the what is going on this IC. Okay, once I click on this right here now, you see where it's connected to. Okay, once I click on this, you see where it's connected to on the IC. Okay, once I click on this, you see where it's connected to. Once I click on this, you see where it's connected to. Understand what I'm trying to say? Okay, this one right here now is for the this one right here is, or let's go with this one. This one is the back camera, that is the rear camera. Okay, let's click on this dot right here. Okay, let's click on this dot right here. Okay, it doesn't show any connection that is closer. Maybe the connection may be far from here. Okay, once I click on this, it's connected to this place. Okay, look at where it's connected to this inductor that is there. There are inductors there. So this pin out is connected to this inductor terminal. So this also. So I'm just trying to explain this thing for you guys to understand what I'm trying to say. Okay, what I'm trying to explain. So that is how it works for this is an iPhone 6 board. Okay, maybe time will not permit, I would have moved further to explain more of this bitmap. So but I hope you guys are understanding what I'm trying to explain. So let's move to this now let's move to the schematic diagram. Let me click on schematic diagram. I've clicked on it. So now remember, before it loads, let me explain what schematic diagram is. Or let's wait for it to load. Okay, this right here is for the schematic diagram. So the schematic diagram now, what is schematic diagram? Schematic diagram is, or circuit diagram, is the standard way of describing the components and the connections in an electronic circuit. It uses iconic symbols. I told you guys it uses iconic symbols to represent the component, with lines representing the connection between the components. Okay, so that is how it is. That is what schematic diagram is. So now let me zoom this schematic diagram. Now for those components on those logic board, the bitmap will just show you the part number. Okay, the board distribution will also, the component distribution will also show you the part number, but they will not show you the value of that component that is there. Okay, so for you to know those components, that is when the schematic diagram comes in. So now, and each of these schematic diagram, they explain how the logic board works. Each part of the logic board, the charging section, the schematic diagram is different. The backlight section, the schematic diagram is different. The should I say the, what they call that one, the touchpad section, the schematic diagram is different. The CPU section, the schematic diagram is different. So I'll just pick one section and explain to you how it works and the meaning of it. So let's go straight, let's move. Let me look for the one that is kind of easy to explain for you guys, that I won't confuse you guys. Okay, so let's search for charging section. Okay, this is the button section. Okay, audio codec. Okay, front camera flex. Okay, let me check. Let me go. PMU. Okay, have you seen each of those sections have their own schematic diagram? This one is trigger, charger, vibe. Okay, Okay, this is the backlight driving circuit, the speaker amplifier. Okay, this is the tri-star. Okay, let me use or let me look for another one. Let me look for another one that is kind of simpler. Okay, let me go down a little bit. Okay, go to properties. Okay, I'm looking for something that will be very easy for me to explain so that it won't confuse you guys, because this schematic diagram is where the main work is. Okay, but you can also use your bitmap and your board distribution to to look for faults. Okay, so this right here I'll be showing you guys. So if you can master this stuff on your own, it will be very very good and nice, because if you go through this diagram, because I can't explain everything about it today because it will take a lot of your time. So let me just go straight. Let me use the previous one. Let me use this previous one, which is the which is let me use this one. Where is that one? For camera, that is the camera section. Let me use that one to explain this particular schematic diagram, how they work. Okay, where is the camera flex button now? It's nowhere to be found. Okay, let's go little by bit. Shouldn't rush. Okay, this is the non schematic diagram, the button flare schematic diagram, the audio. Okay, this is the audio. Okay, this is the front camera schematic diagram. Okay, let me use this one to explain, or let me just go straight to the display. Let me use the display section, like the backlight. Okay, this is the backlight section. Okay, so let me zoom it. Sorry for taking some of your time. So this is the backlight section. Okay, and if you have been watching my video, I've explained what we call the components used on the logic board, their symbols, the numbers and the letters used to identify them. I've explained that for you guys. So now for capacitor, this is the backlight section, and all the component and IC on the backlight X section is being represented on just a graphical written form on the schematic diagram. This is the schematic diagram. This is just a graphical representation of all those components you are seeing. This is for advanced engineers, technicians use it. When once they want to replace a component, then they'll reflect back to this place to know the particular component, that component that is faulty, they want to use. So most of my video you'll be asking me, guy, how do you know how to replace this component? I thought I don't know. Is it by the size? No, most times not by the size. You need to know the actual value of that component. Like for this is a capacitor, and this capacitor is labeled C1547. Note this capacitor is at the backlight section and is labeled C1547, and the value of this capacitor, I've explained what capacitor is for you guys. The value of this capacitor is 10 UF, 10 microfarad. Okay, 10 microfarad, 20% by 6.3 volts. That is the value of this capacitor. Okay, this is an inductor sign. I told you guys this sign is for capacitor and this sign is for earth. This sign right here is for inductor. This is an inductor. It's being represented by L. Okay, and the value of this, look at the value of this inductor. Okay, so that's for that inductor. Let me look if I can see something like resistor. Okay, let me check if I can see something like resistor. Capacitors are just many here. Okay, at the backlight section, we'll still go back to the bitmap and the component distribution. Let me show you how they are being represented there. Okay, I'll show you how they are being represented there. Okay, now I will take note of one component, then we'll go back there and you see there. Now if you want to replace that particular component, you know the IC and component to use. Okay, let me zoom this one a little bit to see if I can find resistor or other component. Okay, this U represents IC. Okay, this is an IC, maybe the backlight IC. Okay, so This is a diode. This is a sign for Zener diode. Okay, is being represented by D. Okay, so this is for diode. Okay, this is for capacitor. This capacitor. Now let's use this capacitor. This capacitor, now the value of this capacitor is, let me bring it up. The value of this capacitor, this is a ceramic capacitor, and the ceramic, and most time on a logic board, most capacitor found there is a ceramic capacitor. Okay, on iPhone logic board or Android, most capacitors found there is a ceramic capacitor. Okay, so this is a ceramic capacitor. They don't have polarity. Okay, so this ceramic capacitor, the value is 2.2 microfarad, that is UF. Okay, by 20% and 25 volt. So now if you want to replace this particular capacitor, and maybe from your bit, we'll go back to the bitmap, then I will come back to this place to explain. Now let's take note of this capacitor, and we'll go back straight directly to the backlight driving circuit part, that the backlight driver. This is the backlight driver. Okay, so we'll go straight to that place, and I'll show you where this capacitor is located at. Okay, this capacitor is 2.2 microfarad, and is the part number is 1530, C1530. So now let's go back to the bitmap. Let me show you. C1530, right? Let's type it here. Let's type it, C1530, V1530, and enter. You see, it took us straight to this, see, to where the component is. Okay, and now and note, this also can, the bitmap also can actually show you, some of them can show you the value of that component. But if you want to know how the connection are being made on that component, then you need to go to the schematic diagram. If you want to know the actual value of that component, you need to go to the schematic diagram. But you can also know the value of that component using the bitmap also. So now this as immediately I type the value of this number of this capacitor, it took me straight to where the capacitor is located at. And let's check if that part is where the backlight section is. Let me take it. Okay, now this is, see, maybe this right here is the display boot tube. Okay, that is the value of this is an IC. Okay, have you seen that capacitor? And if you see very well, once anywhere I put it, you see a blue written right up close at my cursor. Okay, just watch at that cursor. Now you see what that one, now that component, the part name, that the part name is C1530, and the value of that component is 2.2 UF microfarad. That is a capacitor. Okay, so that is for that. So let's go back to that. Let's go back to our bitmap. Let's go back to our bitmap, our schematic diagram, and look for another component. Okay, assuming, let me show you guys something. Let me show you guys another illustration. Okay, assuming this one right here is an inductor. Okay, assuming this inductor is 40, and let's check the part number of this inductor. The part name of this inductor is LU1218. Let's go to the schematic diagram to search it. I've forgotten the LU. Let's go, what is it? LU112, LU11218, 1218, LU1218. Okay, let's go back. Okay, let me go back. Okay, I've come back to the schematic diagram. Now fine, let's find that component, LU118. Okay, LU118, LU, that is an inductor. Sorry, it seems like my keyboard is for. Okay, LU1218. Then let me enter to search for it. Confirm. Have you seen, it took us straight directly to where that component is, and you see the value of this inductor is 1.0 UH. Okay, so that is, it took us straight. So that is the power of this schematic diagram, board view, and all that. Okay, and where that component is located is at the ADI power management unit section. Okay, that is where that inductor is located at. So that is how the schematic diagram works. So now I'll be moving forward to show you guys how this stuff looks on an Android logic board, not only on iPhone. So I'll be moving forward. I'll be, because of time, I won't be doing this tutorial video for other other um models of iPhones. I'll also do it. I'll only do it on iPhone 6. Okay, maybe with time, on my with time, you keep learning more, you can still go and research on your own and you master the system. So let me pause. Okay, now this is an oppo logic board, and this oppo is oppo what, this is an oppo r9. Okay, oppo r9. So this oppo, this is the bitmap. Okay, this is the bitmap, how the bitmap looks like. Let me zoom it a little bit for you to see. Okay, so these are the component. This component right here, the name of this component, this is a connector, not a component. This, remember I said J, anywhere you see J means a connector. This is an IC. Okay, so this is an IC. Let me zoom it in. Okay, this one is a capacitor right here. See, this is an IC. Okay, so let me zoom it in a little bit. So this is the front display of the logic board, and this is the back display. Okay, this is how the logic board looks like. So that is, if you see this, the way it is on an iPhone logic board, that is the way it is on an Android. Okay, that is how the system works. Okay, this right here is the CPU. Okay, and this is the eMMC. Okay, so that is the eMMC. Okay, let me see if we can go to the schematic diagram. Okay, this is the part number. Let me go to the part number diagram to see if I can explain more on that, because this bitmap, the same thing that works on the iPhone, that is the same thing that also works on the other logic board. Okay, so this is the bitmap. Okay, no, this one right here is the part number. Okay, part number diagram. Okay, let me zoom it. Okay, this, as that board is looking like that. So this one right here is, you see, this is an eMMC. This is the eMMC. Okay, and this is the CPU. Okay, so that is it. Okay, I don't want to waste much of our time, so I'll do this video to be a little bit shorter. I don't want to waste a lot of our time. I've used the iPhone to explain this, so that is for that. Let's check the schematic diagram. Okay, let's check the schematic diagram. Okay, let's wait for it to load. Okay, this is the schematic diagram. Okay, this is the schematic diagram. This is how it looks like. So that is it. Okay, so that is all for today. So thank you guys for watching. We'll stay tuned to our next class. We'll be dealing on more videos such as this. So thank you. I remain the Great Tech, and I will always be at your service. Thank you. So thank you for watching. This is the Great Phone Repairs. Please subscribe to my YouTube channel. For online classes and mentorship, you can contact me on the number showing on your screen. Please don't forget to share this video in order to help and assist others.